Hi guys, today I'm going to be designing myself a Raspberry Pi tablet. And we're back. Okay, so I'm going to be using Fusion 360 for this. Let's just pop out my display here. And I'm doing a 4 o'clock broadcast right now because I have massive insomnia and I can't sleep, so I might as well do something useful. So I am literally going to be turning a Raspberry Pi 3A Plus into a tablet, which should be arriving later today. So if I design it now and print it out, I'll have my first prototype ready to assemble sometime this afternoon. So I'm just going to drag on the display, which I managed to hunt down via GrabCAD. This is going to be a 7-inch display. And I think this is a little thicker than the one I'm actually going to end up getting, so I'm going to compensate for that by just designing around these rails and allowing the design to be as thick or as thin as it needs, but it does have these elements placed quite nicely, so I think that should be okay. I will probably end up revising this quite a lot for the second version, but for the first version I will do a very basic framework. Now, because my printer only has a 150 by 150 mil bed, I'm going to have to actually cut this in half or so. And I'm going to double check that by using this inspect tool. And I'm going to see how long it is between these two parts. So as you can see, it's 164 millimeters, so that's going to be too high. But that's okay, I'm just going to end up dividing it in half. So I'm going to begin, as I usually do, by placing my components in the scene as I need. So we're going to have here the display, and I'm going to build everything under the display. So we will go through my list here and see what we have available. We're going to need an MT3608 converter, so that's for the battery. This will be a boost voltage, or a voltage booster, I should say. This will be a full, portable unit is what I'm going to be aiming for. So I'm just going to put that there for now. I'm also going to need, what else will I need? I will need a TP456 module with charge protection. That's what I use to actually charge the battery. So let's move that down here as well for now. And of course, we're going to need a Raspberry Pi 3A Plus, which is my board of choice at the moment because it's the only one you can actually buy. And I do have one sitting on my desk ready to be used. So this will be the brains of the machine. This program is called Fusion 360. This is the hobbyist version, which means it's free for anyone to use who wants to download it. So I'm going to start positioning my equipment. I also need to create a battery, and I think I'm going to need some toggle switches. I'll bring that in a bit later on. Let's get this one rotated first. So this is the MT converter. Let's cancel that, select it properly, and then actually rotate it as it should be. So it's 90 degrees, that's now flat. And because this is a 7-inch display, as you can see, we've got plenty of space around. So what I've got to be thinking about now, what programming language does the Raspberry Pi mainly use? It will use either Python or it will use C. It can also program in Rust, C++, HTML. It doesn't have a main language as such. It will support many different languages, but the default tools it come with usually centers around C++ and Python. And of course, you can program anything for HTML and JavaScript. The Raspberry Pi is well suited for that as well. So I'm going to bring this up. All right, I've got to capture this position first, capture, and then I can move it around. And I'm just kind of getting an idea here. So I'm not going to have any of the ports available because this is a HDMI monitor, which basically means it's going to have a HDMI cable and it's going to be powered by USB, which is literally the only two major outputs of the Raspberry Pi 3A Plus. So there is virtually no expandability in terms of docking stations and stuff. But the good news about this design is it does leave the GPIO free. Which I have some plans for in the future by attaching additional devices. I have a gyroscope on order, which won't arrive until Saturday, but I'm hoping to be able to add a gyroscope to this, so as you rotate your tablet around, it will automatically rotate the resolutions. Hey there, Knobmaster, how's it going? I'm doing well. And I meant to say noob, I'm very sorry. And I'm going to position these. I also need to make a battery, so create a cylinder. Yeah, capture position, that's fine. And I'll do it on this plane, and I'm going to make it 20 mil, and I'm going to make it 75 mil, and this will be our battery. Now it is actually 65 mil, but I'm going to give extra space because there's extra wires to be soldered and that kind of stuff. So that's going to be our 18650 battery, which I should probably name in the bodies. So this is going to be the 18650. And we've got a lot more room to play with than my usual 4-inch display. So it feels almost roomy now. I could actually put a few cells in here by the look of it. So let's move this down here. Is this the handheld? Nope, this is a different one. This is my tablet. So the other one was based around a 4-inch display, which you may be able to see on camera here. I'm holding up. So that's my 4-inch display model. This is my 7-inch display model. So this is a brand new design. Is it possible to change the layout on a controller input board? I don't see why not. It depends on the controller input board. It depends on the specific hardware, I should say. You know, I've got so much space here. I could actually put 2 cells in if I wanted, but I've only actually bought 1, so I will just put 1 cell in here, and I'll just put it centered around here. That way, in the hand, it should be nice and centered. So we'll leave that there. That seems to be plenty of space. It will make the tablet fairly thick. I suppose I could put the cell and give it a bit of a chin. Let's try moving it around. It doesn't cost me anything to move it around and get a feel of what I'm trying to do. So I could kind of put it here. And in the future I could probably put another one on the other side to make it a bit more balanced. But it's going to add that much of a chin, though it's not that much when you consider we got these hooks here anyway. But no, I'm going to put it under the board. Let's have it kind of top down, looking more like a professional tablet, even if it is a bit thick. How long have I been doing IT? I had my first job when I was 18. That was doing a technical support desk, and but basically since then. So I've always done IT as my professional career, either in help centres or building machines, and then I got into educational writing, so quite a lot. Is it possible to change the layout of it? Yeah, I've already read that one, I'm sorry. So yeah, I don't mind making this first prototype a little bit thicker. I can play around with ideas of shrinking it down later on. So I've bought a controller. I want to change the layout. Is it possible? What kind of controller have you purchased? Let's position these components around. So this is the booster board. So we need this one towards the edge because that is where our power is going to be put in. So we'll start by deciding where power is going to go into the tablet. Now I'm going to design this tablet around the basis. It doesn't want to select that at all. Let's try that again. There we go. TP module, and now I can move it. It's a PB Tails controller for the Switch. I have no idea, mate. I'm sorry. I've never used a Switch controller in my life, so I would not know where to start there. I'm going to put this towards the edge. Now, people will probably cringe over this a little bit, but this HDMI needs to connect to the board. So I'm actually going to have a wire go outside of the case and loop back in. And the reason for that is because I want the option of unplugging that wire and then using this as a separate monitor as well. I don't want it just to be a tablet. I want it to also serve a second purpose. So we will connect the, let's grab the Raspberry Pi 3A Plus. So we've got the HDMI port here, so that should be facing in the same direction. Or I could just sort of loop it through. No, I don't want a cable behind it. I'd rather have it sort of over the edge. It will look a little bit messy, but that's okay. I can live with that. I don't mind. So let's capture this and let's rotate it. So now we've got the HDMI port pointing in the same direction as the other HDMI. That's okay. Yeah, it's going all the way around. Let's try that again. There we go. That's what I wanted. And let's move this around and that around and this around. You get the drill. This actually has an audio jack built into it, I think. I don't know if the model I've actually ordered has that built in. If it doesn't, I can use the audio jack on the Raspberry Pi. So that's fine. So I'm going to align this with the edge of the board. So the two HDMIs are basically above each other. So I've got a very short lead that comes with a monitor, I believe. It should be about 25 centimeters. So it should just be a short loop from one connector into the other. And I will be wiring power via these boards here. But I will still need to loop so I'll need to loop this cable. Now I'll need this one access to the outside as well. So well, that's not too bad. If I put a nice deep one there, it will plug in quite easily. Have a little bit of a loop on it, but that's fine. If I can, what software am I using for this design setup? I am using Autodesk Fusion 360. This is the personal edition, which means it's free for anyone not using it for commercial purposes. So we've got access to the audio out, we've got access to the HDMI, we've got power in, which won't be needed anyway because it will be soldered to the bottom of the board. And because it's going to be soldered to the bottom of the board, I can have the boost controller, which is going to be the next thing I need to deal with. Wait for that to lock down. There we go. So let's put that right behind it. Let's capture position. And what I'm really doing right now is designing negative space. So I'm positioning all my components, then I'll draw some boxes around them. And that will become a negative space from another container. So the other thing I want to do is extend this GPIO port, so I will have access to the GPIO pins. Now I'm probably going to do that with a ribbon cable in this first iteration. What would you recommend for someone wanting to learn more advanced IT. IT has many fields. If you want to be a programmer, you might want to be a security specialist, you might be a forensic IT specialist, you could just be a server admin, customer, even just technical support help desk, or building PCs. There's so many different fields that the question really is, what do you specifically have an interest in? Once you nail down the field you want to go into, you can start kind of deciding which paths you want to take, which courses you might want to take, or just do what I did, which was grab a technical support role, have a keen interest in IT. I don't actually have much in the way of qualifications, but I do have a large number of jobs behind me that allow me to learn on the job. But that can be a bit limiting. So if you can get yourself the qualifications, like Cisco qualifications, Microsoft certifications, there's loads and loads out there. So it really is that question of what path you want to go down. And don't worry about locking yourself in too much as well. There's a battery that you could use that would be slimmer, but still powerful enough. Yes, there is. The advantage of the 18650 cells is they're cheap. This will cost me about a tenner. If I want to get a flat battery, I'm probably looking anywhere between £17 to £25, depending on the size of the battery. You can get 1,200 milliamp hour batteries, and I do have some of those. They are much thinner, but they lack the capacity for a Raspberry Pi 3. Those are better used for things like the Raspberry Pi Zero Ws. It's all about ampage consumption. And this board will basically take about 1.5 amps at peak. At normal draw, it should draw about 650 milliamps. Then you'll have the display on top of that, which is about another 300 amps. So you're talking about a 1 amp draw. This is a 2,600 milliamp hour battery. So it should be good for about 2 hours on a single charge with a single cell. I'm going to say maybe an hour and a half if you're doing something intensive like video watching or gaming. Then it will draw more wattage. You can potentially get up to about a 2 amp draw on this, in which case I would expect at minimum about 50 to 1 hour. But of course you can add more cells. There's plenty of space here. It's just that I'm cheap. I've only got one other battery, so that's how I'm designing this particular one. So I've got these boards in nice alignment, which will be good. It's actually quite strange working with enough space. I might actually put the power on the other side. What am I using these Pis for? Mostly fun. Mostly development. I have an idea in the future of putting together some kits, but right now I'm experimenting, coming up with designs. And once I have enough designs, then I will consider actually producing kits that people can buy and build themselves at home. So that's the long-term plan of this. But for now, I'm using this video content, these lives, to see who's interested in what. And as I get an idea of what my audience is interested in, I can then design products towards their interests. So in many ways, what I'm doing today is market research. I'm finding out what engages you, what gets you excited, what you want to see more of in the future. And while I can ask individuals that, what I need is large group data of lots of people and how many views I get and all that kind of stuff. So I'm basically trying to create Tinkerer toys, if you like. I bought several Raspberry Pis a couple of years ago, long before the prices unfortunately skyrocketed. Yeah, I was in a lucky position as well. I had a Raspberry Pi 3, Raspberry Pi 4. I had plenty of Raspberry Pi Zeros, so luckily I had enough Raspberry Pis to coast through the shortage of them. But these Raspberry Pi 3A Pluses, that's what I'm currently using, and I actually bought them this month they are in stock, so you can actually buy them. So I bought them off RS online. They're now sold out, but the Pi Moroni and Pi Hut currently have them in stock. The Raspberry Pi Zero W2 was about $15, and the Raspberry Pi Zero was about $10. The Raspberry Pi 4s went for anywhere between £40 to £65, if I remember. Sorry, I'm swapping between dollars and pounds here. It's because I saw an American educational company, so I've got lots of different prices in different currencies in my head. But yeah, they've gone up to fairly ridiculous prices now, especially for what they are. But this Raspberry Pi 3A Plus is coming in as £28.50, so not the cheapest thing in the world, but it's not bad either. Right, so I'm going to move this one over here. Right, so capture position and drag it over. Let's rotate it. So I'll have all the HDMI on one side and I'll have the charging on the other side. That way the cable should be looped up the top and they won't be getting in the way of everything. That's kind of my vision. But this is a trial and error process. I may hold it in my hands and go, this is horrible, what was I thinking? And that's okay, because we'll go through the prototype phase. And let's bring that down. And bring this down. Let's make it kind of centralized. I want it in line with the other ports. So that's more or less on the same plane. I'll bring that down a bit. Or can I bring these up a bit? Right, so I'm not going to bring it too far up because I want to put another ribbon cable on here so I get access to the GPIO ports, and the cable will kind of come out this end. So I want plenty of space for the cable to go over these two components here. And as the battery is so deep anyway, I don't think it's a big problem. This is probably going to be a bit of a chunky boy, but that's okay. Yeah, I've noticed a lot of videos about the Pis popping up on my FYP. You've obviously taken an interest in them. It's decided that you like Raspberry Pis. And why wouldn't you? They're brilliant devices. Now, I could do this as two sections. No, I won't do that. So that's going to be my basic placement. Yeah, that's going to be my basic placement. We'll have the cell here. Now, I could easily have two of these cells, but I wouldn't want them in series because that would up the voltage. Though I do have a voltage regulator, so I could actually sort that out. However, my TP4056 will not charge above 4.2, so you would have to have them in series. Not series, I mean parallel. So parallel will be side by side with anode to anode and cathode to cathode in a line, whereas in series that will be cathode to anode, etc. So they'll just be like normal AA batteries, which we don't want to have because we're not trying to increase the voltage. We just want to increase the capacity. Do you like working with Arduino boards as well? I do have a few Arduino boards. I don't usually use them because Arduino tends to be more expensive. When you could pick up a Raspberry Pi, which is arguably far superior in terms of specifications and RAM and stuff, and even wireless, I don't see the point in buying one for like 20 quid, which will be what Arduino's for, whereas Raspberry Pi comes in at 360 or 630 with wireless, so it just makes more sense to go with Raspberry Pi. But if Arduinos were cheaper, I would probably go with Arduinos. That's how I tend to operate. I like value for money. I'm going to move this one a bit more centered. And I think that's about it for the components and things. I'm going to try and sleep now. Have a great night. Thanks for answering my questions. You're more than welcome. I wish I could sleep. The only reason I'm up is because I've got massive insomnia at the moment. So let's start drawing the shapes now, shall we? So what I want originally is going to be, right, let's draw around this first. The screen is the central thing, so I'm going to disable the other stuff. And I'm just going to work with the screen for the moment. Now I'm imagining a sliding thing where I can just slide the two pieces over the edge of the screen. So I'm going to try that design first. So let's create a box. Yeah, capture position, thank you. And I'm going to do it in line with the screen down here. And I'm just going to draw a box around the entire unit, nice and crude. Like that. That looks reasonable to me. So that's 137. So that will fit on my print bed. The 172 will not fit on my print bed. The screen will be capacitive touch to start off with. What size is starting with? This is a 7-inch panel. So I will have to cut this in half, and the idea is I'm going to slide them onto each other. So let's go in this direction. Yes, 7. It's about the size of a Kindle Fire 7. So, with the standouts, that's a lot thicker than I thought it would be. Let's see if I can bring that in a bit. No, I'm going to need plenty of material, aren't I? I'm just going to eyeball this. This is literally the first design. So, let's see what we're doing here. So now, what I want to do is draw something along this board. So, create box. Select this plane here, and then I want to draw a nice box. Over this rail. I'm going to give it some millimeters on each side. I hate this sort of right-click weird menu that they have that does not jive with me at all. So I'm going to take that, and this is going to go down here. Like so. And up a bit. I will not be having a cooling fan. There's going to be plenty of space in the ports for air movement, and the Raspberry Pi just doesn't get that hot. Not in my experience. So I'm not going to be too worried about cooling. Right. I'm going to raise this by 1 mil because my printer isn't always accurate. So we've got a little bit of wiggle room there. Should slide in okay. And I will bring back, right, I'm going to duplicate this actually. Right, let's duplicate this. And then move onto the other side. And these are effectively going to be my rails. Like so. Should probably make that a bit deeper. Oh no, that's all right. Because that's just for the rails part. So if I bring back my other object, so body 2, reveal that. And then what I'm going to do now is select that, body 2. Then I'm going to do a subtraction. So target body 2, tool bodies 3 and 4, and then that will then hollow out that area. Yeah, it doesn't work with that. I usually use audiobooks to put me to sleep. But any kind of sound or music or stuff, just it doesn't help me at all, I'm afraid. I'm a little bit awkward that way. I don't get it very often. It's only because I was on holiday for a while and now I'm not. So my body's got to get used to a different routine. Yeah, I've tried brown noises and white noises and noise machines and ocean sounds and all that kind of stuff. None of it ever works for me. All I want is a monotone voice reading something I know very well, I don't have to pay attention to. That seems to do the trick for me. Don't know why, but that's the thing I usually use. So there we go. I better name this one now. Panel housing. That'll do. But thank you for the advice. I appreciate that you're trying to help. Right, that's got to slide in, so I'm going to create a box around these components here. So create box, draw on this, and I'm going to make them oversized intentionally. And I'm going to draw it all the way down there, all the way up here. As I say, this is a very first prototype, so I don't mind being a little bit rough, a little bit crude. I just want to get the general dimensions and then see how it all fits together. Then I come back and I refine the design. Thank you for sending me the 2023. I really appreciate it. So that's a new body. So again, I'm going to bring back now the panel housing, and I'm going to subtract this from it. So panel housing. The pain of SolidWorks. I've never actually used SolidWorks, so I can't really comment on that one. I went mostly on CAD and circuit design software. Right, so let's subtract this one. Right, so that's the tool I want to subtract. There we go. So now we've got the holes there. And of course need to make room for the screen to slide in as well. I'm glad you admire my work. I really appreciate you following me and taking the time to come and say that as well. Hello, it's me. Sounds like bass frequencies. I'll find the name. Yes, I like bass noise. It tends to be But it doesn't have to be. It could be a female voice as well. It's just language. It's just something to stop my brain spinning out of control. Um, that's my biggest problem with insomnia is when I just lie there and I can't stop thinking. That's why I use audiobooks. It's not about sound. It's just about having something to focus my mind on. Let's create another box here. And here. Now, the depth of the screen will be interesting. I'm not convinced that this model accurately reflects the depth of the screen, so I'm just going to go all the way to board, and that way I can adjust it later on. So let's get rid of panel housing for the moment, and let's go all the way down here. And need to make this thinner. Okay, that one's a little bit too thin. Bring that out a little bit. There we go. And we'll bring back the panel housing and we'll do a subtraction. Okie dokie. So hopefully that will just slide in. So let's have a look at our other components. And the cell. Thank you for the roses, I appreciate it. I may actually have this piece come down as a backing piece. So that way I can remove the Raspberry Pi and all the charging circuit when I want to, and then I can use this as a standard HDMI display with touch interface. So yeah, if I design this as two separate components, then I've got a multifunction tool, basically. So I'm going to put the battery as part of the second module. So this will make it a bit thicker. But if I put a nice sort of curved ridge, it might provide a little bit of a handle at the back. So I will make my bad design choices a design choice, if that makes any sense. I will turn a bug into a feature. So I'm going to raise that there. Let's actually make it visible, that'll help. These don't need too much, so we'll leave that where it is. Because I'm trying to think if I put my hand there. I mean, that's not too far up. I think that's okay. Thank you for the more roses. And let's bring that up. I mean, that's plenty of space. Now, because we got the thickness of the battery there, but if I go any higher, I won't have the grippiness. But I do still want to access that GPIO pin. I suppose I could just put a small module. Now, I have it the same sort of size. Yeah. Yeah, I'll make it like a docking station. That's what I'm thinking. Yeah, because why make one tool when you can make two? There, these are pretty much fine as they are. I'm going to put this in alignment. Position, capture. It would be easier if I just used a flat battery, but like I say, I'm trying to keep costs down as much as possible. This entire project is round the Raspberry Pi up to 30 quid. I paid £40 for the IPS panel, so that is 70. These power modules are nothing, they're like 2 quid for both, so that's like £72. Add another £10 for the battery, we're at £83. So I'm basically building an £83 tablet, taking into account the amount of filament I use, probably no more than £3 or £4 worth. We're talking about £85 or so for this entire tablet, which isn't bad when you look at tablets. I think the Kindle Fire ones are about the same price. So, and I'll have modular flexibility and power Raspberry Pi behind it, all that kind of stuff. I could actually put Android on it if I wanted to, and there's nothing stopping me having multiple operating systems because all I've got to do is swap out this SD card unit. Thank you for the follow, Java. I appreciate it. Now I'm gonna put the power in the center. Right, let's get that position first. So the TP 4056 position capture. I'll move that into a more central position, like so. What's that lock into? And I'll move this to the edge as well. This is Autodesk Fusion 360. And okay. And let's. Don't actually need to move this around because you won't actually see it anyway, so it doesn't really matter. Is there enough room for a ribboned cable to go above there? No. So I will lower that down somewhat. Position capture. I did just position. Why is that not capturing? Select, position, capture position. Thank you. And bring it down. That's more or less in line. I am at the moment. It will depend on work. My hours recently changed, so I'm not sure where that's going to end up with. But I tend to do lives and make YouTube videos at the same time, so this will end up being encoded as a higher quality version. I am making myself a Raspberry Pi tablet. So this is a 7.5-inch display. This is the Raspberry Pi beneath it, with all the power systems it needs to charge a battery and be run from a battery. So think Raspberry Pi with a built-in UPS. And right, there was actually a. Actually, I better account for that. Hang on. I got a little bit ahead of myself, so let's disable this button. Yeah, I haven't accounted for this, so I need to draw another box around this audio jack, and I'm going to give plenty of position capture. That's fine. I'm going to give plenty of room around it because I don't think this model is 100% accurate to what I've bought. So by giving these extra margins, printing it out, and having something to test, now I'm going to drag that all the way there as well. New body, that's fine. And that's probably a bit too deep. Let's try resizing that. There's the top of it. So if I bring that down, most audio jacks are standard, so 2mm on that should be pretty safe. And now if I get this other one back, panel housing, select that, panel housing selected, and I shall now remove this object. And then it should slide and I will have access to it. So if I look down here, we've got an audio jack that we should have access to. If it's in a slightly different position, up or down, this will compensate for that. And in the second version, I can bring this all back in again. So if I now disable the housing panel, No, the 7-inch display. So that's what I'm basically looking at right now. There should be some cutouts there. What happened to those cutouts? I'm going to try. They are in there. Okay, so I've done something a little bit wrong there. There should be some PCB. I haven't accounted for the PCB. I just went down to the PCB. I didn't go down far enough. Okay, that's fine. That's something I can compensate for. So now I'll draw yet another box. Create another box here at PCB level. And I will draw it to the same level here. There we go. I want a bit more wiggle room because, again, first prototype. Right, that didn't go quite as well as I wanted. Let's try that again. Create box. This surface. Draw box around surface. Thank you. And I want the box to go upwards. Upwards like that. That should be enough room there. I've already got cutouts around here, so I'm not too bothered about that. I'm going to assume there's components and solders and things on the underside of this, so I want to bring it down another 2mm, and I will do that by clicking here and extruding downwards by 2mm. That should give me a bit more room to play with. Then I select the panel housing, and I will do my subtraction trick. So combine, cut, panel housing, and remove body 7, and OK. So now when I hide this, that's what I was looking for. Okay, that's what I was looking for. You popped up on my FYP page. I'm glad. Cool. Are you designing something to 3D print? Yes, I am. Any ideas why my Windows 10 PC would blue screen after removing a second hard drive? No, I actually have no idea. Unless... No, you'd have to have a really weird system configuration for that to be an issue. I don't know off the top of my head, sorry. Okay. Now this is actually going to be split in half, and then each side is going to slide onto the edge of the screen. So I need to design a mechanism for that. Create a box to start off with on that plane. I'm going to draw it right through the middle. I'm going to say to 0, 0, 1, and I'm just going to split it down like that. Okay, so now we've got two halves. So panel housing 1, we'll call that A. No, that's going to be left. And panel housing right. Then I can just put some very simple tabs for now with a screw hole in. That's probably the easiest way of doing it. Talking of screw holes, I need to bring up the tablet again. And there will be some screws here for the... actually, I don't think I need to screw it in, but it sort of slide up and down a little bit, maybe. Now, this is more of a framework anyway, so... Okay, let's create here a box. I do like my boxes. And I'm going to draw a box here and here. I'm going to cut that in like that. I want it nice and thick because it's going to be holding onto the whole mechanism. But I don't want it so thick that it actually interferes with the rails. So let's bring that over here slightly. Made that quite deep actually. That should be fine. This is literally the simplest mechanism I can think of. Yeah, that was too deep, so I'll try that again. Create. This I did a pressure fit. No, I'll do a proper cut. Let's do a nice long one. Like so. I'm going to over exaggerate everything for this. Let's go down about 5 mil, like that. Then create a box. I'm going to be using PLA Plus, which is a bit tougher than normal PLA. And I'm giving plenty of space because it will be screwed down anyway. So if I bring that up like that, that's too thin. Let's fill that out a bit. There we go. Now I'm going to hide left panel. Yes, I've had a fight with my sleep cycle and I've lost. So join that. I'm going to extend that down a bit. No, I won't extend that down a bit. That would be a silly thing to do. It should be joined. That should be fine. It looks like it's physically joined there anyway. So just to make sure, I'll extend these walls in so it is physically joined. And we'll bring this in. That is now a join. And we'll bring the other one in and join as well. It's nice to see you as well. And let's actually select the right doodah. Bring this in like that. And join. There we go. I could probably do it the other side as well. Probably should actually. But first of all, let's bring the other one in. And let's make a 3mm hole. Let's bring that down and let's make that, how deep is that? 15 mil. What screws do I have? Where's my thickness there? So on my 3 mils, oh, actually I've got some M4s. Let's see what it's like with 4 mil. Yeah, that'll work. So I've got some long ones, M430s, M420s, so I could actually go through the whole thing if I wanted. And if I do that, then I repeat the sides that, yeah, that's what I'll do. So I'll cancel the hole for now. And repeat the operation. I may just make the side panel for now, or the screen panel for now, print that out, see what it looks like, and then design this bottom panel. So I'm going to hide this equipment for now. I'm just going to focus on the cell, not the cell, the IPS panel holder. So this will be a monitor to start with. And then I can come back and let's grab box. I'm actually going to grab the size of this again. Doesn't need to be that way. That's fine. I'll just do it the same way as before. Let's not think too much about this. Bring that down here. And can I grab the bottom? No. In that case, I shall make that an object, new body, and I shall click on OK. Then I'll move it down that way. Just like that. Same effect. In fact, I'll copy this object then, and I can do it on both sides. So I'll copy that and just drag it over here. Oh, didn't copy. Right, let's create that there. Let's copy this and let's repeat the action there. And OK. And I'll just copy this again and down. Right, so let's copy this one. OK, copy this one. Copy this one. Thank you. Thank you. And this one. So now that gets this subtracted. And then this one gets this subtracted. And thank you. As soon as I'm able to, as soon as I get enough interest in it, I'll start making real moves towards making kits. But I've got to get enough interest first, otherwise it's not worth my investing a few £1,000 into it, which is what it's going to end up costing. Right, this one, subtract this one, and then this one, subtract this one. And this one, subtract this. I did not click on subtract. That was a silly move. Let's try that again. Doesn't matter which side I'm doing. Select the tool, remove it. Thank you. And this one matters. So select tool, remove. Thank you. Right, so now I've got those in place. Hi mate, just curious, does Raspberry Pi Zero, can it use a retro game emulator too? Yes. In fact, you can. The GPI Pi was a Game Boy styling case centered around the Raspberry Pi Zero. So you can use it for retro gaming and emulation. Thank you, Brian. I appreciate it. Right, so I'm basically trying to create that joint now. Here. Thank you for the follow. I appreciate it. Right, create box. And in there, extend it down. Hide the left, is it? Yeah, that's fine. Okay. And then I will bring this in. So join and what's going on there? Let's cancel that because I'm not quite sure what happened there. Okay, I think it was okay. Yes. Okay, I can actually just click on the other side. What's the price and spec for the Raspberry Pi Zero? Normally about $10, but right now there's a shortage. So you'll probably be lucky to get them for 30 right now. But there are compatible versions around, like Banana Pi, that's worth looking into. The one I'm using right now is a Raspberry Pi 3A Plus, which is readily available at £28.50. When they become available, yes. Right now, I'm standardising on the Raspberry Pi 3A Plus because they're easy for people to get their hands on. Join. That's what I wanted. And it's not too close to the rails. That's fine. That's what I wanted. Right, let's bring this left side back. Now, if you're wondering why I'm splitting this case in half and sliding them onto each other, it's because my printer is not big enough for a 7-inch display. So I've only got a build area of 150 cubed. So yeah. Create box. Bring this up. And I want to hide that one and join it to this one. And then same as before. US gets difficult, to be honest. Sending abroad tends to get very expensive very quickly, and it puts a lot of people off. So it will be UK to start off with. But it depends how big I get. It depends how much money the company makes. So I can't promise anything, I'm afraid, for the US. Create box. Bring this back. So this goes up and across. And that's on level, yeah. So hide this one again so it doesn't join. Okay, and then I'll just extrude this surface to merge it all as one. And join. There we go. So basically I've got those now to screw everything into. So when I slide the left side on there, I can just screw it in. So so I have M30, M6. Let's see if I can get away. I've got M10s. Okay. So let's go for, whoops, that's a bit big, isn't it? Let's go for an M4. Now I'm actually going to make this 3.9 so the teeth have something to bite into when I screw. That is 10 mil deep, so 10 mil's a bit much, I think. Let's try 6. And it's a flat point. I think that's okay. Yeah, that works for me. So that will allow me to screw that in, and I'll just repeat the procedure now for each one. And one for here. My first kit, when I make it, will probably be a Raspberry Pi Zero base kit, not Zero, a Pico base kit, because they're quite cheap and plentiful to get my hands on. I am an absolutely terrible salesperson, so I may end up taking you up on that offer. It's a bit crude, but it works. And I will be printing a cover that slides on over the top anyway. So it doesn't really matter if it's a bit crude. That's probably good enough to get started with. All the cables will be looped around the edge anyway. There's nothing I can really do to avoid that because I want to be able to reuse the panel as a normal monitor. So maybe the first video I make on this will be the touchscreen monitor for my Raspberry Pi, and then I'll add the bottom module that connects to the bottom, and then it turns into a tablet. So it'll be a transforming thing that I can move around, use with my main laptop, use on other computers, anything basically with a HDMI out would be usable with it. I need to buy some speakers. I need to start adding external speakers to these things. Right now they'll be limited to earphones, and I do have Bluetooth on it, which is fine. So I think that's good enough to start off with. Right, so how deep is this in there? They'll be concerned about the HDMI port, so I'm going to try bringing this in. Connect on that. Bring that in. Let's try that. That's a bit more flush now. It's probably still a bit far in there though, so let's bring that in a bit more. Yeah, that'll work. Right, now we're on the edge of the screen, so let's undo that. Oh no, that's all right. That's all right. Because it's the little pins in the middle. I'll bring it in. Let's have a look at that. I mean, it's deep enough. It's going to be this chin here that causes the issues. I just know it is. So I'm going to bring it in 1 more millimeter. And I think I can get away with that. Yeah. Yeah, I think that works. Eventually, this will evolve into a ribbon cable. So rather than going on the outside, it will be a thin ribbon cable and an internal connection. But right now, I'm just making it as basic as possible. Right, I don't need this edge that thick as well then if I've made the other one thinner. Let's bring this in as well. I think that works. Yeah, so in theory, both these pieces should just slide onto the screen, screw it in, and then put a cover on the outside. I want this facing upwards because I want access to the SD card. And I'll run a ribbon cable on the inside so I get access to the GPIO ports. Yeah, I think that works. I think I'll 3D print this. So I will disable all of these. And that will be my basic model. So I've got the rails on the inside there where the case should just slide. I've got the pieces to bolt it together. I think this is just a put it together now and see what it feels like. Is it possible to make a second monitor with a USB rather than HDMI, if that makes sense? Yeah, there are absolutely USB Type-C connections out there which will carry a HDMI signal. I have a little USB Type-C to HDMI converter. But for the model of display I've purchased, it's a HDMI in, and there's no other option on that particular monitor. But yes, you can actually absolutely buy panels that will run off USB Type-C, assuming your machine supports HDMI over USB Type-C. You will be using screw insert posts to connect the pieces together. Yes, I will be. I'm using M4s. So it's literally slide around the display and bolt it. If I had a printer with a bigger surface bed, I would just print this out as one piece. But I have a 150mm limit. So if I'd bought the Adventurer 4, I would have had extra space, but I didn't. I got the Adventurer 3 for about £300. And to be fair, though, it's been fine up until this point. Every other project I've worked on, like this, I've got the cover the wrong way around. Like this Raspberry Pi handheld I've been building, absolutely fine. So 150mm is pretty big, but of course a 7-inch screen goes beyond that size. So this is ending up being a how big was that? Yeah, 168mm. So it's just 18mm over what it can actually handle. So that's made this design a bit more complicated than it necessarily needs to be. That was the other thing I was going to do. Is 7-inch touchscreen. Okay. Or actually, no, I won't do that this time round. Until I get the screen in my hand and I confirm it is the size I think it is. Because right now I'm basing it off a 3D model. I haven't taken any real world measurements. It looks very similar to what I've purchased. And I basically wanted to get the package in the post later today take my 3D print and assemble it pretty much immediately, because I'm working all day today. So I'm only going to have a couple of hours after work to do anything. This will either be a horrible disaster or it will work really well. We'll find out. But I think this is a good starting point, and I think this is where I'm going to end this particular live and video demonstration. You see my methodologies, you see me sort of umming and ahhing about the design process. I'm simplifying it now to just a simple monitor case with these screw points, which is fine, and that's it. So yeah, later on today you should see a video appear on TikTok showing what an utter disaster this turned out to be, and those are always the most fun, I think, when something goes horribly wrong. So yeah, it's just a matter of feed this into my 3D printer now. This will probably take another 4 or 5 hours to print all this out, maybe even 7 or 8, given the size of the components, and I can move on then from then. So thank you everyone for joining me this morning and sharing in the pain of my insomnia. Thought I'd do something useful with my life rather than just lying in bed going, I can't sleep. So I might see if I can go and grab a couple of hours sleep before work now. But yeah, that's it. You've seen a very basic design process. This will be ongoing. There will be future videos. And thank you all for staying up with me this evening. I hope you're all enjoying your new year, and I hope to see you all back for the next live. Just so you all know, this video is going on YouTube. So that's youtube.com/@CKenthusiast. All these long form live videos will go up there. Once I finish filming this, I will just upload it, and it should be up there in the next hour or so. So please subscribe to my YouTube channel as well. Thank you again all for joining me, and have a fantastic morning.